Okay, in today's video we're going to talk about how parallel light rays interact with concave and convex lenses and mirrors. So we're going to look at all four of those devices and see what happens when parallel rays either strike those mirrors or pass through those lenses. Okay, so the first one we have here is our convex lens. You'll notice it bulges out on both sides. That's what we call a biconvex lens. The second one is the lens that bulges in or is caved in on both sides. This is called a biconcave lens. And what we want to be able to answer at the end of the video is why, when you look at the image of my face through the concave lens, does it appear right side up, but when you look through the image of my face through the convex lens, it appears upside down. So in one case, it's upside down with the convex lens, and in one case, it's right side up with the concave lens. Upside down, right side up. What's happening to the light as it passes through each of those devices to cause it to be upside down, the image to be upside down in one case, and the image to be right side up in the other. And of course, we want to do the same thing with the mirrors. This is a concave mirror. It's caved in on one side, so you'll notice that the image of my computer is upside down. When I pass my hand across the keyboard, you'll notice my hand comes across the top of the mirror. The image of the computer is upside down. In this case, we have the convex side. The image of the computer is right side up. Why is it that in this side, the convex side, the image is right side up, and why is it that in this side, the concave side, the image is upside down? Okay, so let's go through and see if we can figure that out. We're going to kind of just summarize what we've seen so far. Convex lens, image upside down. Concave lens, image right side up. Convex mirror, image upside down, and then the convex mirror, the image was right side up. So what is the same about these and what is different about them that causes those images to appear that way? And we're going to group these two together. We'll look at these two first. Hopefully something is similar about these two that causes the image to be upside down, and what's the same about these two that causes the image to be right side up, and how is this pair different from this pair? Okay, and we're going to do this using parallel light rays. We're looking at an object that is far away, and the light rays are coming in parallel. They pass through that lens, and they're going to be refracted. Now, they're going to be refracted at each boundary, but we can approximate that refraction by showing the refraction or the bending of light at the center line right here. So here's the object. The light rays are passing through the lens, and you, with your eye, are looking at that object. You look at the object through the lens, and what happens is the light rays, when they come through that lens, they are refracted or are bent in such a way that they all pass through a single point. That point is known as the focal point. Okay? They converge, and therefore we call this lens a converging lens. And you'll remember, as long as the object is far away, is beyond the focal point, the image will appear upside down, or what we call inverted. So the image is inverted. Okay, so a convex lens is also known as a converging lens, and the image most of the times will appear inverted. We'll talk about when it can appear right side up in future videos. Okay, let's do the same thing for the concave mirror. This is the shiny side, the concave side of the mirror. There's your eye, you're looking at an object, maybe it's your face you're looking at or some other object like my computer in this case. You'll notice the light rays come in parallel. They strike that mirror, they're reflected in this case, and they're reflected in such a way that they all, once again, will pass through the focal point. They converge at the focal point. These converge at the focal point, these converge at the focal point. Therefore, we call this a converging mirror, and the image appears inverted. And as long as the object is beyond the focal point, then the image will appear upside down. If we bring the object inside the focal point, then something different happens, which we'll talk about at future videos. Then it will appear right side up. But for parallel light rays that are coming in from greater than the focal point, the image, the light rays converge at the focal point, and the image is inverted. If they're coming in parallel, they're going to converge at the focal point, and the image appears inverted. Okay, so you can see we have the opposite shapes: the convex lens, the concave mirror. They're both called converging devices. This is a converging lens, a converging mirror, and the image is going to be inverted or upside down. Okay? Now we're going to look at the concave lens and the convex mirror. And in this case, once again, light rays are coming into the lens. They're going to pass through the lens. In reality, they get refracted at each boundary between the air and the lens, but we can approximate that refraction by showing it refracting at the center line. Here's your eye, you're looking through the lens at the object, the light rays are coming through the lens towards your eye. But in this case, after they pass through the lens, or as they pass through the lens, they're going to be bent in such a way that they diverge. So they're going to move away from each other. They don't converge, they diverge. That therefore this is called a diverging lens. A concave lens is a diverging lens. Now, how does your eye or your brain form an image if those light rays are moving away from each other? They have to cross or intersect for an image to occur. But what happens is your eye does not know that this bend occurred. It does not know that this refraction occurred. It assumes the light rays traveled in a straight line. If these light rays are followed back by your eye, by your brain, you'll notice that they appear to come from the focal point. Do they come from the focal point? No, they do not come from the focal point, but they appear to come from the focal point. And therefore, we get what we call a virtual image, which we'll talk about virtual images in a future video also. Okay, but a concave lens is a diverging lens, and the image appears erect. And in this case, the object, regardless of where it's placed, will always look right side up or erect. Okay, this is a diverging lens. The rays are bent in such a way that they appear to come from the focal point. So when you bend these, you have to bend them with your ruler so that you can draw them back to the focal point. They all have to look like they're coming from the focal point. Do they come from the focal point? No. Okay, that's the definition of a virtual image. Okay, now let's do the same thing with the convex mirror. Here's the convex mirror. It's shining on this side where the light rays are coming towards it. The light rays strike that mirror, and what happens, they're going to be reflected. And how they're going to be reflected? They're going to be reflected so that they diverge away from each other. So a convex mirror is also known as a diverging mirror. Now what happens? How does your eye form an image from this mirror? Okay, your eye is taking those light rays in. It does not know that they changed direction or were reflected right here, so it assumes that they traveled in a straight line, and they will appear, once again, to come from the focal point. So students often ask me, well, how much should I bend these? Okay, they diverge, but how much do they diverge? They have to diverge just like these so that they appear to come from the focal point, so that they can be drawn straight in a straight line back to the focal point. The focal point for a diverging mirror is behind the mirror. Okay, the light rays appear to come from behind the mirror. Do they actually come from behind the mirror? Of course not. A mirror is a solid image, solid object. You cannot see through a mirror, but your eye thinks that they come from a mirror. Now, if you look carefully at this mirror, you can see that it looks like, I think it looks like to you, and I think I can see it too also when I look at it, that the image is behind the mirror. Is it really behind the mirror? No, it's not. Okay, so it looks like it comes from behind the mirror, but they do not. That is, again, a virtual image. And regardless of where we place the object will always be right side up and will always be a virtual image. Okay, so let's just summarize this page. Concave lens, convex mirror, opposite shapes. They're both diverging, therefore the image in both cases is going to be erect or right side up. Okay, so that's the difference. In one case we have a diverging device, in the other case we have a converging device. And we can summarize all that information right here. Convex lens, converging. Concave mirror, converging. Therefore the image is going to be right side up most of the time, not always, okay? Most of the time, as long as we're beyond, as long as the object is outside the focal point, okay? Greater than the focal point away. All right, now the other two, concave lens and its opposite shape convex mirror, they were both diverging devices, and therefore the image is always going to appear to be right side up. It'll always be right side up regardless of where the object is, which we'll show in a future video, and that's always going to be what we call a virtual image, okay? And in this case, the object appears to come from behind the mirror, and if you remember, in this case, the object appears to come from behind the lens because you were over here looking at it. The image is actually formed back here on the other side as your eye and your brain trace those light rays backwards. Okay, so that was a lot to go over. I hope you found that helpful. If you did, you can leave me a thumbs up in the comment section, or you can leave me a comment below. Thank you very much for watching, and we will see you next time. Thank you.